Greetings, ladies and gentlemen. This is Mark Anderson from Keller Community College, and this is our third video in a three-part series to talk about solving fractional equations. And this is a pretty good one because we are going to look at clearing the denominator. This is a technique we used back 2 chapters ago. Whenever we had an equal sign, it is legal for us to multiply both sides by the denominator or the lowest common denominator, and this will allow us to get the answer. And what's going to be great about this is we can even use a quadratic formula now to find the possible answers for the problem. So let us begin by looking at this problem here. We have a z over 1 and a 6 over z minus 5. So if we multiply both sides by the common denominator, which would be z minus 5, what you get is simplification over here, which gives me an answer of 6. And z minus 5 times z is z squared minus 5z is equal to 6. Now, to solve for z, since I have a z squared and a z, I'm going to get everything to one side of the equation. And so this gives me z squared minus 5z minus 6 equals 0. And then I'm going to use the quadratic formula, or factoring, to solve this problem. And factoring would be easier since I can find two numbers that multiply to make negative 6 and add to make negative 5, so z minus 6 and z plus 1. I'm going to have my z minus 6 equals 0 and my z plus 1 equals 0. Move the 6 to the other side and move the 1 to the other side, and so my answers are 6 and negative 1. And you can check these answers by plugging the 6 in here and seeing this is 6 over 1, which is 6. And then if I plug negative 1 in here, this would give me negative 1 on this side, negative 1 on this side. Both answers work, so I'm done with that problem. Now, someone might just say, but Mr. Anderson, this is the same thing as cross multiplication. And I'm like, yeah, you're right, this is cross multiplication, and so is the second and third problem. But when you look at problem number 4, we're going to have some different manipulation there before we can cross multiply. So here we're going to multiply both sides by x minus 2, x minus 4, x minus 2, x minus 4, and this allows us to do some simplification here. So this distributes here as to 4x squared minus 16x. This x minus 4 simplify and distributes here, so this is 12x minus 24. So it looks like I'm going to move everything to the left-hand side here and get an answer of 4x squared. If I subtract the 12x from the 16x, I get a total of negative 28x. And if I add the 24 to both sides, add the 24, so now both of these are gone from the right-hand side to make 0. This is going to be 24 on the right-hand side. Now, before I do any kind of factoring or quadratic formula, and I know a lot of you will be jumping into using the quadratic formula right here, I can factor out a 4. And if I do that, I get x squared minus 7x plus 6 equals 0. Holy moly, look at that. Look at that trinomial right there. That is beautifully factorable. And two numbers that multiply to make 6 and add to make negative 7 are negative 6 and 1. And the 4 is then equal to 0. Now I could divide both sides by 4 right now, and 0 divided by 4 is 0. But I could still solve for x just like this. We would not set 4 equal to 0. That's just silly. 4 is not equal to 0, and it's not a variable, so there's no algebra that works with that. So my answers in this problem are 6 and 1. And you can check them out in the problem. They'll both work, so those answers are checkable, and yes, you have the solution of 6 and 1 for this problem. So moving on to the next one here, let's scroll on down. Okay, so in this next problem here, I think a lot of my critics might say you could just cross multiply, but I'm going to keep consistent and multiply both sides by the lowest common denominator. The lowest common denominator of x minus 1 and x plus 1 is but one of each, and this will simplify, and this gives me a FOIL problem to do in the numerator, which in this case would be x squared plus 3x plus 1x. And again, we wouldn't write 1x in our final answer, but it's there to help me add the two middle terms together. And over here, if I divide these out to get 1, then I would FOIL the x minus 1 and x minus 1, which would be x squared minus 1x for the o and the I, and then plus 1. Now, I think it'd be best to move all the things to the left-hand side, so I'm going to subtract the x squared from both sides. I'm going to add the x. I'm going to add the x to these two So again, these are going to get simplified as well. And then I'm going to subtract 1. Subtract 1, so boom, 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 boom. All gone, equals 0. So now here's what I have. This is equal to 0. So I'm going to have now x plus 1 plus x plus x. That's a total of 6x. And then this is equal to, this is going to be plus 2. And now I just realized that all my x squareds simplified, so I'm going to move the 2 back over to this side. You know, if I saw that ahead of time, I could have avoided that, moving that 2. And this is going to give me an answer of x is equal to negative 2/6 or negative 1/3. Here's my final answer there. And you can go and check your work there and see what you have in the problem. There is the one solution for that. At this moment, I'm not sure I would multiply everything by the x minus 4. The better step would be to move this x to the other side. This is going to make my process a little bit easier. So if I can get the problem to look like a fraction is equal to another fraction, I totally am going to do that. So this is 2 plus x right here. And now I'm going to multiply everything by x minus 4. It might have been easier to write this as x plus 2, so I think I will rewrite that before I multiply it by x minus 4. What that's going to allow me to do is give me an easier FOIL problem. So 4x minus 1 is equal to x squared minus 4x plus 2x minus 8. Alright, I'm going to move everything to the right because it looks like that is going to give me the best situation for my problem to FOIL or use quadratic formula. So 0 is equal to x squared minus 8 plus 2, that's going to be negative 6x. And negative 8 plus 1 is negative 7. Oh goodness, this is great. I've got 2 factorable problems. Negative 7 plus 1. Alright, so 0 is equal to that, so I'm going to have x, let me just rewrite it this way, x minus 7 equals 0, x plus 1 equals 0. Solving for x is going to be equal to 7, x is going to be equal to negative 1, and both of these answers will check out if you plug that into the problem up above. This is really great. We're going to move into our final 2 problems here, and these problems are going to get a little hectic. So let's give ourselves a lot of space, a little bit of warm-up time, because we're not going to move anything from the left side to the right side. We are just going to clear the denominator by multiplying everything in this problem by whatever the denominator is. So in this case, I'm going to multiply the top and bottom by 3x plus 2 and x for each of these terms. So 3x plus 2 and x, and then 3x plus 2 and x. So the 3x plus 2's go away, which leaves me with 8x. That's nice. The x's then simplify to 1, which then if I multiply by 2 times this is 6x plus 4. And then over here, I'm going to have a negative 3 times this binomial of 3x squared plus 2x. I just put those together. I'm going to multiply all of that by the negative 3, so this gives me a negative 9x squared, and this negative 3 times this 2x gives me negative 6x, and I'm going to just add these 2 to both sides. I'm going to add this because what I want to do is create my 0 over here, and by moving this to the other side, you'll notice that now I have in front my 9x squared, and I'm going to have my 6x with the 8x and the 6x. So this gives me a 9x squared plus 20x, that's a 6, 6, and 8, plus 4. Now, this, my friends, is a great problem to solve using the quadratic formula. But you also might be aware that there could be a cool pattern here with, you know, the difference of the, like maybe square, you know, shoot, there could be a pattern because the first term is rootable and the last term is rootable, so you may want to check if this works out to be 3x plus 2 and 3x plus 2, which doesn't. So we're back to using quadratic formula where a is equal to 9 and b is equal to 20 and c is equal to 4. So if I plug this in, my driver is negative 20 plus or minus the square root of b squared, or 20 squared, minus 4 times 9 times 4, which is going to give me 256, all divided by 2 times 9, which is 18. So what I have is negative 20/18 plus or minus. The 256 is simplifiable down to 16/18. So now I have 2 possibilities. I have the plus possibility where negative 20 plus 16 gives me negative 4/18, which is negative 2/9. And then the minus situation, if I go negative 20 minus 16/18, gives me negative 36/18, which is negative 2. And both of these answers do work in the problem. So our final problem here is going to be a pretty big one since I'm going to have a lot of FOIL in this. So I'm going to give myself a lot of room to write on the left-hand side, and here we go. So x plus 5 and x plus 2 is my common denominator. So that means that I need every term to be multiplied by x plus 5 and x plus 2. And the 4 is going to be multiplied by x plus 5 and x plus 2. So x plus 5 simplify, x plus 2 simplify, and the 4 is going to get multiplied by this crazy binomial here, or two binomials here. So here's what we've got. We've got our x plus 2 is going to be multiplied by our 3x minus 1, plus our x plus 5 is going to be multiplied by our 2x minus 3. And on this side, I'm going to multiply 4 times whatever this FOIL is, the x plus 5 and the x plus 2. Now this problem isn't necessarily difficult, it's just going to take you a little bit of methodical time and process to do the FOIL and then to check to see if you got everything right. So x, let's begin. X squared and 3x makes a total of 3x squared, and then this makes minus x and then plus 6x minus 2. That is our first 4 terms of this these two binomials. Now here's our next 4 terms. So I got 2x squared minus 3x plus 10x minus 15 is equal to 4 times whatever this FOIL is going to be. So let's actually figure out that FOIL. So I got x squared, and I'm going to have plus 2x plus 5x. Let's see here, plus 10. All right. So now I'm going to multiply all these by 4. So this is 4x squared plus 8x plus 20x plus 40. Whew. So looks like I am going to combine all of these on the left-hand side. I'm going to kind of move everything from the right to the left, so this is going to be equal to 0 when I'm done with it. So it looks like the 3x and the 2x, which makes a total of 5x, is going to then be subtracted from 4x, which gives me nothing but an x squared. All right, so far so good. So I'm going to lose, let's see, I have a 8x, I'm going to subtract from the x, and the 20x, I'm going to subtract from this one here. So if I lose 1, and I lose 8, and I lose 3 more, that's negative 12, or excuse me here. Let me check my work. All right, so I've got a x. Oh, I got the 6x here too. Almost forgot about the 6x and the 10x. All right, so here we go. Starting over. Losing 9 and then gaining 6 is like losing 3. Losing 3 more is like losing 6. So I've lost 36, but gained 10. So I've lost a total of 28. 28. Okay, let's count that again. Losing 9 gives me a positive 3. Okay, so far so good. And the positive 3 then loses 3. Oh, okay. I see how I did that. All right, so it looks like I'm still getting an answer of negative 28x. I just am mentally adding these up wrong as I'm doing them. Okay, so moving on. Let's go with the these. I'm going to take my minus 2 and minus 15. Makes minus 17 right there, but I'm going to subtract 40 from that. So I'm going to lose from that negative 15, I'm going to lose a total of, or 17, I'm going to lose a total of 40, so that's 57. Oh man, I don't even know if this is factorable or not, but it totally is factorable. This is unbelievably factorable because the two numbers that multiply to make 57 are 19 and 3, if you can believe that. That's crazy cool. And x is going to be equal to 19, because if I set x minus 19 equal to 0, solve for x, I get 19. If I set x plus 3 equal to 0, minus 3, and I get x equals negative 3. Wow! Wow, this problem, right? All those terms, especially those x's in the middle there. Man, I finally got that right answer I was looking for. So x is equal to 19, x is equal to negative 3. These are two answers that work for the problem, and thank you for watching the video.